possible in the case of complex numbers. All right, just as in this 4 upon 2, we say this is 2. We cannot say that 4 plus 2i upon 2 plus I or 2 plus 2i. We take 2 common, that is okay. We cannot divide this, all right, because we cannot compare two complex numbers. So what we tend to do is write that into simpler form, which is a plus ib form. What I mean by this, suppose you have 1 plus 1 upon 2 plus 3i. What I can do with this is 1 upon 2 plus 3i multiplied by 1 minus 3i and 2 minus 3i. Clear? 2 minus 3i and 2 minus 3i, divide and multiply with this number. This is clear?
Yes, sir.
So the numerator remains the same, but this is a, this is b, this is a, this is b. I can use a plus b, a minus b, which is a square minus b square.
Yes, sir.
So 2 minus 3i upon 4 minus, this is 3 square is 9, I square is minus 1. So 2 minus 3i upon 4 plus 9. So 2 upon root 13 minus 3 upon root 13 I. This is clear?
Yes, sir.
So whenever you have like this a complex number, always try to convert this into this form. Okay?
Yes, sir.
All right. So please note it down.
Sir, how is it 2 under root 13 in the last?
Okay, that is my bad. This is just 13.
Okay, sir.
All right.
Done, sir.
All right. Few questions for you. Write each in the form of a plus ib. 1 upon 3 minus 4i. 5 plus 4i upon 4 plus 5i. 1 upon 1 minus 2i plus 3 upon 1 plus I multiplied with 3 plus 4i upon 2 minus 4i. All right. Tell me when
Yes,
you're
sir.
done.
So can you explain the last one?
All right. Last one is also very simple. What we can do here is we can take just LCM, right? So 1 minus 2i, 1 plus I. If you take LCM, this is 1 plus I plus 3 times 1 minus 2i. All right.
Yes, sir.
Or what we can do, this is A, you can rationalize and simplify this, and then multiply. We'll get the same answer. Okay. So this is 1 plus I plus 3 minus 6i upon this is 1 plus I minus 2i plus 2. All right.
Yes, sir.
So 4 minus 5i upon 3 minus I, 3 plus 4i upon 2 minus 4i. We can multiply this further. Model like this. So 4 into 3 is 12 plus 16i minus 15i plus 20 upon this is 6 minus 12i minus 2i plus 4. Okay.
Yes, sir.
So 12 plus 20 is 32 plus I upon 10 minus 49. Now you can rationalize by multiplying this. All right, whatever there is in the denominator, just change the sign and multiply and divide. Okay.
Yes, sir.
We simplify this further.
Sir, before this, if we rationalize the second term, then it would be the same answer.
Yes, any step you can rationalize. Here you want to rationalize this and this,
Okay, sir.
right? Any step you can rationalize, no worries. And the proper term is not rationalization. All right, I'm using this for the reference. All right, but this is not rationalization.
Okay, sir. Sir, I'm getting 13i plus 6 divided by 6 minus 2i.
Okay, so if you multiply with this, the last term, then this is 320 and plus 32 into 14 times I plus 10i and minus 14, right?
Yes, sir.
And in here, this is 100 and plus 196. You can simplify this and get the answer, right?
Okay, sir.
Okay. So multiplication and division is clear.
Yes, sir.
Okay, one more question for you. Then we can move on. 3 plus I root 5 times 3 minus I root 5 whole divided by root 3 plus root 2I minus root 3 minus I root 2. Let's simplify this.
There is I root 2 the same as root 2i?
Yes, root 2 and I root 2 are equivalent.
Sir, is it 7 by root 2i?
Okay, how to solve this? This is a plus b, a minus b, right? So 9 plus 5 upon, this is root 3 minus root 3 is 0, plus root 2i plus root 2i. So 2 root 2i. Okay, so we can multiply
Yes.
I and I here. So 14i upon 2 minus 7 upon root 2 will be the answer. Okay,
Sir, why are we multiplying I?
we never want a complex number in the denominator, right?
Okay, sir.
What did this question? 1 upon I.
Yes, sir.
Same way, never have a number which has I in the denominator. I hope this is clear.
Yes, sir.
Okay, let's see one more question. All right, and remember this one, a plus ib, whichever is in the term with I, you have to multiply with this a minus ib upon a minus ib. If you have two terms, then this will be c plus a, c plus a, like this. All right, I terms will change the sign.
Okay, sir.
So 1 upon 1 minus cos theta plus 2y sin theta. Please try to solve this.
Sir, can you explain?
Just a minute. All right. Okay, how we can simplify this? See here, this is the whole term A and this is B, right?
Yes, sir.
So we can multiply this as 1 minus cos theta minus 2 sin theta I upon 1 minus cos theta minus 2 sin theta I. All right.
Yes, sir.
So numerator remains the same, 1 minus cos theta minus 2 sin theta I. And this is whole divided by 1 minus cos theta whole square minus 2 sin theta I whole square. No, this is whole A and this is B. This is A and this is B. Clear?
Okay. Yes, sir.
Okay. So now this becomes 1 minus cos theta minus 2 sin theta I whole divided by. Can we open this? And I square becomes minus 1. So plus this. Okay.
Yes, sir.
All right. Just a minute. So 1 minus cos theta minus 2 sin theta I upon this is 1 plus 4 sin square theta plus cos square theta minus 2 cos theta. All right, you can leave it as it is. All right, no worries, because further simplification requires some topics of some formulas of trigonometry. All right,
Okay, sir.
I hope this is clear.
Yes, sir.
All right, so division is absolutely clear.
Sir, can I note it down?
Okay, try this on your own. All right, once try this on your own, then you can note it down if you cannot. All right.
Okay, sir. Sir, can you show the last step? Sir, is it 4 sin square theta?
right? This is 4 sine square theta, right?
Sir, can you read the denominator in the last step?
1 plus 4 sine square theta plus cos square theta minus 2 cos theta.
Okay, sir.
Okay, so this is clear.
Yes, sir.
Okay, next topic we have is conjugate of a complex number. Right, conjugate of a complex number, very simple. If z is a plus ib, then conjugate it is written as z bar. All right, this is denoted as a minus I. Find what is with I, change the sign of that number. A will not be affected by this. Only the imaginary part is affected. All right.
Yes, sir.
If Z1 is A minus IB, then Z1 bar will be A plus IB. All right.
Yes.
Can you tell me what will be Z bar?
3 minus 4i.
Very good. If Z is minus 2I plus 1, then Z bar will be
2i plus 1.
very good. So this is clear, right?
Yes, sir.
Okay, note it down.
No.
All right. So conjugate will not be used like this. What they will use is properties of this conjugate. Write down properties of conjugate. What is the first one? If you take bar of z bar, then it replaces the value itself. Second one, if two complex numbers are added like this and you have to take whole bar, then this will simply be z bar plus z2 bar. Same with subtraction. If two numbers are multiplied and taken bar, then this simply is z1 bar, z2 bar. You can break the bar. Same with division. All right,
Yes, sir.
please note it down.
Done, sir.
Okay, few questions. Find conjugate of z equals to 1 upon 3 plus 4i. Alright.
Yes, sir. So, sir, should we like rationalize it first?
Yes. You should first rationalize, then take conjugate.
Sir, is it 3 plus 4i by 25?
Correct answer. Few more questions. If z is equals to 1 minus I upon 1 plus I, you can use the properties also and then rationalize. Alright.
Okay, sir. Sir, can you do the last one?
Okay. Let's see. They are saying 1 plus I whole square, 3 minus I. First, you can simplify this. This is 1 square plus I square plus 2I whole divided by 3 minus I. Alright.
Yes, sir.
So I square is -1, 1 minus 1 is 0. So this is 2i upon 3 minus I. Alright.
Yes, sir.
Now we have to find z conjugate. So I can use here also this property. So this will be 2i bar upon 3 minus I bar.
Yes, sir.
So minus 2i upon 3 plus I.
Yes, sir.
So minus 2i, I can multiply 3 minus I upon 3 plus I upon 3 minus I. Now we know how to simplify this.
Yes, sir.
Got it?
Yes, sir.
All right, please simplify. Tell me the answer.
Sir, is it minus 6i minus 2 by 10?
Yeah, correct answer. All right. You can multiply this I, but if this is the correct answer, this will be plus 2 minus 6i whole divided by 9 plus 1, 10. Right? This is the answer.
Sir, I got minus 2.
See, minus 2i into 3 is minus 6i.
Yes, sir.
Okay, this is minus 2, right? Minus 2. All right.
Okay, sir.
Give me just 1 second. Well, the question is saying find x and y if this whole number is the conjugate of this number. All right.
Yes, sir.
Can you try this or do you want me to solve this?
Sir, I'll try.
Okay. So please try this. I'll give you a few minutes.
So can you explain?
Okay. See, very simple this question. All right. In class 11, 12, just try to understand the question first. All right. They are saying this is the conjugate of this. So if I take this as this z, then can I say z bar is given as this number x minus iy times 3 plus 5y?
Yes, sir.
So can you simplify this?
Yes, sir.
Okay, let's simplify. So this is 3x plus 5xi minus 3iy, and this is plus 5y.
Yes, sir.
And what will be z bar? If this is z, then z bar will be minus 6 plus 24i. All right.
Sir, but that is Z, right?
So I took z bar. So z bar, this will become positive.
Oh, yes, sir.
Now take the I together. All right. Just take the i's together and compare. Just give me 1 minute. I'm getting a call. 1 minute. So what we can do is, this is minus 6 plus 24i. We can write the items together and the real part together. This is 3x plus 5y plus, if I take I common, then this is 5x minus 3y, right?
Yes, sir.
So now if two complex numbers are equal, then real part will be equal to the real part, right?
Yes, sir.
And 5x minus 3y will be equal to 24.
Yes, sir.
Now we have two linear equations. Do we know how to solve this?
Yes, sir.
So we can solve this,
Yes, sir.
right? So remember, whenever trying to solve complex number questions, this is the method we tend to use. All right.
Yes, sir.
Just do what they are saying and compare. You'll get the answer. Okay.
Yes, sir.
Okay. So I hope conjugate is also clear. All right, Harsha.
Yes, sir.
Okay. So please try NCRT also. First two exercises, I believe you can solve. All right.
Okay, sir.
Okay, then see you in the next class. Ask me any doubts if you have in the next class.
Okay, sir. Thank you,
All
sir.
right, take care.